Class?
Yes.
Tree?
Yeah.
Don't seem so excited. Alright, so differentiable linear approximation Newton's method. I will say it again. I hate doing this method. I hate approximating. I really do. I would rather just find the actual value versus we're approximating for a value instead of actually just finding the value. It's weird. Anyway. So, but this is one of the things that needs to be covered. Alright, find the differential of a function and interpret it geometrically. Right here. So, if y is equal to f of x, the derivative can be found to finding dy dx, which is also f prime of x, or it's also the limit as x approaches 0 to get my slope. Right there, that's the slope formula. That's the slope. And then this one right here, where the triangle refers to delta. It's a Greek letter delta. Delta x refers to the change. So how much change is there in x? So if I'm starting with my first x, I go to my second x, okay, there's a reason why they're both my x's, okay? So there's something in common there, okay? I just need to pick better x's. Put a ting. Come on, I'm trying at least. Anyway, so it's the difference in the x's. How far are those x's apart? And that's what it's referring to. Delta is the change. Therefore, okay, dy dx is approximately f prime of x delta x. So times delta x times whatever the change is there. When delta x is approximately 0 but cannot be equal to 0. Because in the limit process, I want my two values to get so close together that they are the same thing. So I want my change to be close to 0 but not 0. Does that make sense? Hopefully? Tree? Did I say too many words already? Yeah? Is it too early? Do you have these notes? Oh, okay. Do you have these, Vincent? You have these, right? No? These two have it. Why is it these two have it and you don't?
Did you? I said Lappy.
Oh, you got it? 3-5?
Yeah.
Nah.
I don't like.
You don't even need
I
my
don't like
notes,
the
do you?
angles getting hurt.
Okay. Alright. Okay. Let y equals fx be differentiable function and let delta x denote a change in x. The differential of x is denoted by dx. That's important. Dx, so change in x. Dx is defined as it is change in x but cannot be equal to 0. And the differential dy is f prime of x times dx. So f prime of x times dx. So this is actually a little bit of algebra, so I'll show you what it did. I had dy dx is equal to f prime of x, right? Yeah. So that's the change. So watch this. Multiply both sides by and I'm left with dy is equal to f prime of x times dx. So understanding that this can be moved, multiply both sides by dx, that's actually going to be key to a lot of the stuff that we're going to be doing with the integration later on. Okay. So that's important. That's how I get that down there. So for the function, f of x is equal to x times e to the x. Find the differential of dy. Okay. So we know what this is first. We already know what this is. So that's my f. Let's find f prime. What rule am I using here? I'm using the product rule, right? So product rule. So let's go ahead. So f prime of x is equal to, what's the derivative of x? 1 times e to the x plus, since it's product rule, it's going to be x, right? Times the derivative of e to the x. Yeah, you were right saying e to the x first. I was just putting this in order. X, e to the x. And then derivative e to the x is just e to the x, like that. Okay, so that's my product rule. So that's my f prime of x is equal to e to the x plus x e to the x. Okay, so I have that right now. And so let's go back to this. So dy dx f prime times dx. So I don't actually have any value yet to put in. So that means that it's going to be f prime times dx. So my dy is equal to f prime, which is my derivative, was e to the x plus x e to the x times dx. Now, what am I going to do with this now? The next part says, compare dy to delta y when x equals 0. So what am I doing with x? I'm going to plug in 0, right? So I'm going to plug in 0. And for dx, so that's my delta x is equal to 0.5. So I'm going to replace my delta x with 0.5. So let's go back a little bit here. dx is delta x. Right? So this is my delta x. So this is going to go into here. This is going to go into here. Yes? Okay. All right, so I'm going to go back to this page over here. So I'm going to say my dy is equal to e to the 0 plus 0 e to the 0 times 0.5. Alright, so 0 times anything is 0. E to the 0 is 1. 1 times 0.5 is going to be 0.5. So dy is 0.5. And I'm going to compare that to, says right here, compare it to my delta y. Alright, where's my delta y at? Alright, so my delta y is, did I already have it? Where'd it go? Find that delta y, dy to delta y. I'm changing y, because it's the delta y over delta x. Going back. See the formulas right here. Right here. Delta y divided by delta x is equal to f prime of x times delta x. So f prime at 0 times 0.5, that's what I just did. And then what was the other one I was looking for? Like I said, these formulas always get me confused, so I apologize if I'm getting you confused too. Because I just found the dy, and then gotta look at my notes. So I got that one. Delta y. Oh yeah, because they didn't actually show it over here. So my delta y, it should be here. So delta y is equal to f of x minus plus delta x. Times dx. Minus f of x, there it is. Alright, so from this one right here, I'm going to go back over here. And it was delta y equals f of x plus delta x Alright, so I'm going to plug in my values. So I have the value of when x equals 0 and delta x was 0.5. So that's f of 0 plus 0.5 minus f of 0. My original problem was So this together is going to be f of 0.5 minus f of 0. F of 0, I put a 0 here, and that's going to be anything times 0 is 0. And then I need to find f of 0.5. And that right there is going to be an approximation. So I'm going to calculator that piece. That was, I'm going to go over here, I'm going to plug it in, x times e raised to x, enter, and then I'm going to go back over here, and it's supposed to be using the bars of 0.5 8244, or since we're using AP calculus, which is always using 3 decimals, so 824. So now that we're looking at this, we have this piece right here is my delta y. My dy was 0.5. And my question said, compare this to this. So I'm going to find the difference in between these two. So finding the difference, I'm going to subtract. So how far are they apart? So absolute value of 0.824 minus 0.5 is going to be 0.324. Did I get that right? Alright, and the reason why we use absolute value here is because I'm looking for the change, the difference, how far they're apart. So that's why I'm using this, because if I want to find the distance something is apart, distance is one of those things in math that is always going to be positive. So even if both of those were negative, that's why I have absolute value bars, because I want the change in that. Alright, now let's do it again, but this time I'm doing 0 and 0.1. So 0 and 0.1 use the same thing. Let's start out. dy is equal to, what was that? That was to the x plus x e to the x times dx. This is when x equals 0 and delta, was it x 0? X 0 and delta x is 0.1. So I know this looks all kind of super crazy and stuff. This is algebra. You just have to understand what formula we're plugging it into. And that's the same problem I have currently. That's the reason why I have to keep going back to my notes on these things. Alright, let's plug in. So if I plug this in, I get dy equals e to the 0 plus 0 e to the 0 times dx, which is 0.1. So my dy is equal to 0.1. Alright, we're comparing that to my other one. My other one, which is going to be my delta y, is equal to f of x plus delta x minus f of x. There you go. And I'm going to plug in using the same thing. So I get delta y is equal to f of x, which is f of 0 plus 0.1 minus f of 0. And f of 0 is going to be 0. And go back to the calculator. And this time I'm plugging in 0.1. Vars and 0.1. And I get 11 or 0.111, right? 111. Because that fourth digit, 5, is going to round it up. 0.111. Now compare. So if I'm comparing, I would have absolute value 0. That should be a 111, but my board's not liking me. Minus. So my change is going to be 0.011. What can I say as I'm getting closer and closer, or smaller and smaller delta x's? Can we see it yet? Christian, can you see it? What's happening? The closer what? Okay, closer to 0. So as delta x gets smaller, remember delta x, that's the change in my x's. As it gets less and less change, a smaller and smaller change, what's happening to my dy and my delta y? Are they getting closer together? Are they about the same? Okay, let's do the last one then. Compare these two, x equals 0 and delta x equals 0.01. So doing the same thing. So I get so dy is equal to e to the 0 plus 0 e to the 0 times 0.01. So all this right here, so my dy is going to be equal to 0.01. And then my delta y is going to be f of x plus delta x minus f of x. Stop messing around. Alright. I plug it in, so delta y is equal to f of 0 plus 0.01 minus, and f of 0 is still 0. So I'm going to go to the calculator and it says f of 0.01 vars and I get 0.010. Okay, we're rounding to 3 digits. Yes, you could end your rounding with a 0. So whenever rounding, because that next number after that's a 1, isn't it? So that 1's not going to change it. So whenever it says round to 3 digits, make sure you have 3 digits, even if it is a 0. A lot of people make that mistake. Now, again, compare. Compare this to this. They're getting closer and closer to be the same thing. So the whole point is actually trying to get this approximation, getting them to be converging onto the same thing, which is my derivative of that. So using linear approximations to find those. So my dy uses derivatives, where my delta y is just looking in the change in between those two. All right. There it goes. And interpreting the results, and that's what we were trying to get at, that they are changing together to eventually just be the same as delta x becomes closer and closer to 0. Alrighty. So let me see where we're at. Alright, linear approximation to a function. What time we got? Is that 51? Okay. So let's hold this off till tomorrow, because I think I've already beat you guys up enough today. Not yet. Maybe. Possibly. A little bit. So you should be able to actually do the first couple of problems from the homework with just what we did by identifying the delta x and, you know, doing the dy or delta y. So make sure you all like, share, and subscribe.